Number one. This is really, like, at the beginning of pre-calc, I could have given you guys y equals 1/2 x squared, and you certainly could have graphed the parabola for me. I mean, that is like y equals, put it in a graphing calculator. You guys are very good at that. So we're going to just switch it a little bit for today. And so the idea is we want to flip it around so that in this particular form, we're working with x squared stuff on the left, or I should say squared values on the left and single powers on the right. Now, as you get better at working with these types of parabolas and finding given information, you wouldn't have to switch it around anymore. You could certainly work with it the way it was given, but I want you to do it the same way every time. So the idea then is that I want to get rid of the 1/2. I don't want the 1/2 here, I want it over there. So if I divide by 1/2 on both sides, or multiply by 2 on both sides, this is the equation that we want to get to. Where is my vertex? I'm not adding or subtracting anything with the x or the y, so both of them are 0, 0. Right away, you should be able to tell me, do we have a vertical asymptote or a horizontal asymptote? Oh, excuse me. I meant a vertical axis symmetry or horizontal axis symmetry.
Why vertical?
Because x is being squared, things are going up or down. So, axis of symmetry is at x equals 0. It's kind of the same question of saying, do you have a vertical or horizontal parabola? To determine whether the parabola now is going to open up or down, because we know things are going up or down, you will grab the 2 and you will set that number equal to your 4p. So 4p equals 2, divide by 4. P is 1/2. You don't have to, but you can write it in there, positive 1/2. What does that tell us? We have some sort of parabola opening up. I will move up 1/2 to my focus. So that p-value tells you how far to move away from your vertex. So we're going to move 1/2. So that's going up. So I add that to the y value. And then we also go down the same amount. So negative 1/2 is the directrix. So your parabola will always move away from the directrix. Axis of symmetry and your directrix are always perpendicular. You have to do what's called completing the square. When we get into the ellipse and the hyperbola, you're completing the square twice for every equation that you do. So we're in chapter 10. If you haven't figured out how to do completing the square, since we did it back in chapter 2, you need to make sure you stop in and see me, and we need to practice some completing the square bumps. So the idea will be, I have a y squared. So I'm going to keep all the y's on the left. And I'm going to send the x and the 5. So negative x goes to the other side as a positive x, and the 5 goes over to the other side as a negative x. So anything that contained a y stayed over here on the left. Now, what do we have to remember for completing the square? I got to have a leading coefficient of 1. So I'm going to factor out the 2. Negative 4 divided by 2 leaves me with negative 2 there. We'll be putting in some new constant there. Now, when we did what was called vertex form back in chapter 2, we worked on one side of the equation. So we had y equals I did all this work and we always went for a net gain of 0. Now we're back to working on both sides of the equation. So if I add 5 over here, I add 5 over there. So once you have that leading coefficient of 1, you can take what we call the middle term, the -2. We always cut it in half or divide by 2, literally giving half to the length, half to the width, and you get -1. I put that in parentheses because I will use that later, but also you don't mess up on your calculator. -1 squared is 1. So when I put a 1 there, we did a dotted line back in chapter 2 to double check, is there anything in front of the parentheses? Yes, there is. So that number really is a 2. So by adding 1, I've actually added 2 because of 2 up front, right? So we do the exact same thing on the other side. If you are saying -2, what you are remembering is working on one side of the equation. If you add 2, get rid of it right away, so you 0. But now I'm working on both sides of the equation. So you do something over here, you do something over there. All right, so then I have a 2 in front of. The reason why we're doing all this work is we get a nice quadratic on that blue step. It'll be y. Remember, this is the number that we're going to use again, so that comes over here. -1 squared, so we kind of skip the whole factoring the quadratic step. We know it's going to be y minus 1 squared. On the right-hand side, I have x minus 5 plus 2, which is x minus 3. Where do we want the coefficient that we're going to set equal to 4p? So that it's the same every time we do these problems? I want it over here. So when I divide by 2 on both sides, what I really end up with is y minus 1 quantity squared is equal to 1/2 x minus 3.
Could you do 1/2 x and then 3?
All right, so now we're ready to graph. Where's my vertex? What did you say though? What did you say?
She didn't say anything, Cat Smart.
What did you say?
0-0.
She said 3-1.
What?
That is. That's right.
Yes, it is.
Everyone always says 1-3. They always say 1-3 because it's left, right. They always say that.
Did you just change it?
You have to go grab the x first, and it is 3 y value 1.
Can you like a little bit?
I knew this.
Kusanagi?
People have
Okay, so 3-1.
Because he doesn't have any.
Hey, Isaac, come on, man. Vertex 3-1. Now, is this a parabola that's going to go up and down or left and right? Where's our,
Left and right?
okay, where's the axis of symmetry?
3. Sorry, yeah. Say again.
3.
3? Oh, is that 1?
How did you know it was left or right?
because the y is
Yes,
squared.
sir.
Because the y is squared. When the y is squared, things are going left or right. So the last thing we have to do is work with the focus and stuff. So we're going to take this 1/2, bring it off to the side. We're going to go 4p equals 1/2. When you divide by 4, p is only 1/8. So we're not moving very far when we go to directrix and focus. However, because p equals a positive 1/8, I now know that it's going to the right. So positive, things are opening up or to the right. Negative, they would open down or to the left. So if I move 1/8 inside my parabola here, I would have a focus at, I would just write 3 1/8, comma 1, and then I go backwards 1/8, and that's x equals, I would just say 2 and 7/8. You're just adding an eighth to the 3 and subtracting an eighth from the 3 for those two things.